Okay, there was a break of about half an hour between these two videos that I did, and I realized that I made a boo-boo in signs again. Okay, so let's go back to this example. We had, you see, my mistake was that 2 times -1 times 4 gives you a -8. I had put a +8 over here, so please fix that in your notes. That's a -8. So -8 minus 3 gives you a -11. And I forgot that this gives you a -2, and a -2 and a minus, that gives you a +2. So the answer would have been -9 for this example, not +3. Oh boy, I'm sorry for that mistake. But anyways, I hope you fix that. So -8 here, and this gives you a +2. So -11 plus 2 gives you a -9 for the value of that determinant. Okay, last example. Ladies and gentlemen, I am going to use number 3 on page 620. Number 3 on page 620. So in the previous example, we solved the system of equation by using Kramer's rule. The system was a 2 by 2. System of 2 linear equations. Now we want to solve a system of 3 linear equation by Kramer's rule, and that's as highest as we go. Beyond that, it's just too much work. I mean, even for these, you can use calculators, but I just want to show you how to do it by hand because it's good. Okay, so here's the system. Hopefully I won't make a mistake in signs. Here's the system. X minus 2y plus 2z equals to 7. 2x plus 2y minus z equals 5. This is number 20 on page, number 3 on page 620. Number 3 on page 620. On top of the page. 3x minus y minus z equals 6. So this is a little ugly, all right, system. And I can use Kramer's rule. So here we go. I'm not going to do the whole thing. Okay, I just want to show you maybe 1 or 2 parts of it. The rest is pretty much the same. So how do we determine the D determinant? So those are all the coefficients for x, y, and z. So you have 1, 2, 3, -2, +2, -1, 2, -1, -1. I hope I didn't miss a sign. Oh, you see, I did miss a sign. This is a plus. Oh, shame on me, shame on me. Let me double check. X minus 2y plus 2z equals to 7. 2x plus 2y minus z equals 5. 3x minus y plus z equals 6. Okay, so 2, -1, 1, -2, 2, -1, 1, 2. If you were in class, you would have been catching me right and left with all these little mistakes that I make. Okay, so let's do a 3 by 3 determinant. So 1, -2, 2, 2, 3, -1. So this diagonal first, so that gives me a 2. This diagonal gives me a -1, -2 times -1, that's +2 times 3. That gives me a 6 plus 4 times -1. That gives me a -4 minus, open up a parentheses. Now let's do these diagonals. Okay, so that's 3 times 2 is 6. 6 times 2 is 12. That's a +12. Plus -1 times a -1 times a 1. That's a 1. Plus 2 times -2, that's a -4. So evaluate these. That's an 8 minus 4 is a 4. That's 13 minus 4. 13 minus 4 is a 9, but you have a negative, so that gives you a -9. So this gives you a -5. I hope I'm correct, because otherwise it's gonna waste a lot of time. So now let's do d of x. So how do I evaluate d of x? So the coefficients of x will be replaced by these constants. So I'm going to do them in red. So 7, 5, 6. And then the other columns stay the same. Negative 2, 2, negative 1, 2, negative 1, 1. Okay, so we do it again. 7, negative 2, 5, 2, 6, negative 1. Okay, so let's do these. So 7 times 2 is 14 times 1 is 14 plus. Negative 2 times negative 1 is positive 2 times 6 is a 12. And 2 times 5 is a 10. 10 times negative 1 is a negative 10. Okay, minus. Let's do these. So that's 12 times 2, which is 24. And then these guys, which is plus 7, because negative times a negative is positive. And then last, 5 times negative 2, that's negative 10. Okay, so that's a 26, right? 26 minus 10, that's a 16. And minus 24 plus 7 is 31. 31 minus 10 is 21. And 21 minus 16, that gives you a negative 5. Okie dokie. Now, how do we do d sub y? So basically, d sub y, you replace the y coefficient in the d determinant by the constant. So the x coefficient stays the same. These stay the same. But I'm going to replace the middle column by 7, 5, and 6. Okay? And then copy them. Right, 1, 2, 3, 7, 5, 6. Okay, so let's do this. So we have 5 plus negative 7 times 3 is negative 21 plus 4 times 6 is 24 minus, now these diagonals, that's 15 times 2 is a 30 plus negative 6 times 1 is negative 6 plus 14. Okay, so negative 21 plus 24, that's a 3 plus 5 is an 8 minus 30 minus 16 is 24. 24 plus 10 is 34. 34 plus 4 is 38. So that gives me a negative 8. Negative 30, sorry, what am I saying? Negative 30 for d sub y. And the last one, which I'm not going to finish, d sub z. So I'm sure you know now, you replace the z coefficients by the constants. So you will have 1, 2, 3, negative 2, 2, 1. The other coefficients stay the same. So the last column will be 7, 5, 6. And you just do the same thing. Oh, let's just do it. Finish the problem. So you have 1 times 2 times 6. So that's 12 plus negative 10 times 3, that's a 30, and then plus 14. No, I made a mistake. That's a negative 30. Okay, no wonder I was getting a big number. So that's 2 times 5 is negative 10. Negative 10 times 3 is negative 30. Okay, minus these guys. Let me do it in red. We're almost done. Hang in there. All right, so what do we have? We have 3 times 2 is 6. 6 times 7 is 42. Plus 5 minus 24. So that's 26 minus 30. That's 26 minus 30. That's negative 4 minus 47. I'm getting tired. 47 minus 24. That's 23. And wait a second, something is not jiving here. Something is wrong here, because this, did I do this wrong? 1 times 2 times 6, that's a 12. Negative 2 times 5 is negative 10, times 3 is negative 30. 7 times 2 times 1, that's a 14. Okay, so 12 plus 14, 26 minus 30, that gives you negative 4. So that part is correct. 6 times 7 is 42, plus 5, so 12 minus 24, so 42 plus 5 minus 24, that's 23. Huh. That gives you negative 27. Okay. Made a mistake somewhere. But anyways, let me figure that out later. So anyways, how do I get my x? That's d of x over d. So what's d of x? D of x is negative 5. I'm sorry, d of x, yeah, d of x is negative 5 over d, which is negative 5. That gives you a positive 1. So x is positive 1. Y is d of y over d. D of y is negative 30 over d, which is negative 5, and that gives you a positive 6. And then d of z, and the z value is given to you as d of z over d, and there is the mistake here because I should not get a decimal, but I do. So I'm going to check that in a second. So how do you show your final answer? It would be x comma y comma z. So your x is 1, your z is 6, and whatever you get for z, you put it right there, and it's finished. Okay? All right, so that's Kramer's rule and how to apply it in solving a system of 3 linear equations. All right, I'm going to check that mistake, and I'll be right with you.